Good day to all viewers, and just like to take you through in this short clip, not exceeding 7 minutes. Now, what is the purpose of this session? It's on the messenger ribonucleic acid, the new generation vaccine. Now, I created this especially for those who would want to have a broad concept of what this technology is all about, and also to understand how it's being applied as a vaccine to fight against COVID-19 virus, and also for those who just wish to have a short, concise explanation involving the basic sciences behind the creation of this new vaccine, largely based on cell biology and genetics. As it is, there is a whole host of information, useful information, detailed information on the internet describing mRNA technology, and please feel free to check on them, and so that you can appreciate any technical details or scientific terms that you wish to have. Now, essentially, the RNA is an unstable protein in the cell. And in order that the researchers or the pharmaceutical companies are able to retain its effectiveness, they have to provide for an environment that is up to minus 70 degrees centigrade for transport. And then, when it is in the hospital, to thaw it to between 2 degrees centigrade to 8 degrees centigrade for a period up to 5 days before it is being used. Now, if you have other feedback, please let me know, so that we can all appreciate our efforts to help expand our knowledge among ourselves. And we hope for the best outcome in our global fight against COVID-19. A good day to everyone. This will take probably about maybe 4 minutes. A very quick one-page explanation of the difference between traditional vaccine and mRNA technology. Most of you know that for traditional vaccine, it is a weakened form of virus that is being produced, what they call attenuated virus, and it is usually cultured in the laboratory using the egg, chicken egg. The danger is that there's possibility of introducing foreign elements into us, the human beings. So they got to be careful, and so they got to sanitize the whole process, make sure that only the weakened virus is produced. Now, the whole idea of traditional vaccine is to produce, to mimic the entry of the entire virus in its form, so that our body immune system can begin to produce antibodies. And because of the care, of this, the production of this attenuated virus, it takes between 4 to 5 years before production into a private sector. Now, let's look at the mRNA technology, messenger ribonucleic acid. Now, most of you would already know that this is how typically the coronavirus looks like, with spikes, surrounding it. And what the lab does is that sometime last year, they really have done that. They sequence the genome of the spike protein. This is the spike protein here, right? It's called the in vitro transcription of a piece of the spike protein. And most of you would know through your study of Bio 101, the 4 bases: adenine, guanine, cytosine, and thymine. Let's say this is a sequence of the spike protein of the mRNA. Now that it is produced in the lab, what they do is that in order to protect itself, because it's highly unstable, and also protect itself from the body's ribonucleases from destroying the mRNA, they insert the mRNA into this fatty sheet, what they call the lipid nanoparticle, right, and into the vaccine. So there you have it. There's a vaccination into your body. Okay, and the mRNA replicates itself. It gets into your cell, it replicates into what we call the spike protein, because it has this genetic information, and it begins to go out, protrude from your cell outer layer here. Okay, this is called antigen presentation. Now what happens is that it kickstart a detection system by your body immune system. It detects what called the foreign particles or foreign antigens, and that's where your lymphocytes begin to go into action to produce antibodies. How it's done, the T cells will release cytosines, and that will create the B cells, and then it becomes a plasma cell, which in turn produces the antibodies, which recognizes the spike protein here. Okay, so it is trying to mimic, right, the entrance of the virus in your body. Well, some people say that, well, researchers, we can always use the plasma cells of those who have recovered from COVID-19, and so that they can, produce this antibodies. Well, that's another research altogether. But so far as this mRNA is concerned, this is just one page or summary of what it's all about. And for those who are interested in detailed technical terms, there's really a lot of better literature and videos than this. You can kindly refer to them. So I hope you have an idea of what mRNA technology is all about. Thank you.